So there's actually a really fun symmetry to being here today, because the first time I ever presented to a group this large was as an undergraduate here at Harvard, and it was because of Harry that I was doing it. Back then, Harry, I was a CS major, and Harry was my academic advisor. And he had asked me to join this thing called the Faculty of Arts and Sciences Information Technology Committee. I don't know if you remember this. And so I was the student representative. My first time being on a committee, very educational experience, has served me well in my career. And back then, this is an organization committed to sort of bringing information technology to the entire Faculty of Arts and Sciences community. And the topic of the day was bringing high-speed Ethernet to every dorm room. Because it's hard to imagine, this is just 25 years ago, but it was sort of this, the web has happened since then. Just to have some context, when I came in as a freshman in '91, 20% of the graduating seniors had email addresses. When I graduated in '95, 100% had email addresses. When I came in as a freshman, there was no web. When I graduated as a senior, there was a web. The mosaic had happened. And so this is really, I feel very lucky, actually. I was a student at this sort of, epochal time in sort of information technology. And anyway, he had asked me to be in this committee, and the committee's job was to get all these dorms wired. And so I use this talk as a chance to go back and do some sort of information archaeology. So I'll share with you some fun things. One of the things that I put together was an Adopt a Dorm program. So these are students helping fellow students get their computers plugged into this newfangled internet. Because back then, you didn't just plug it in. You had to install cards and special drivers, and it never worked. And so it was a major pain in the ass. Anyway, this is a questionnaire we put together, and we sent around in April of '93. And I want to share a couple things here. Do you have an email account, yes or no? How often do you check it? And the most frequent option here is every day, right? That is the most frequent opportunity for checking email. Every month, I don't use it or other options. What do you use the internet for? Anonymous FTP, Waste, W-A-S. I had to go back and Google, what was Waste? I didn't remember. Gopher, who remembers Gopher? Gopher? There you go, okay, Gopher. Telnetting to a BBS, Usenet News, a computer class, other. Again, no web. This really dates where we were at that time. So put this in your head back in 93 now. That's the state of where we were. And so I remember putting together this bulletin for the fellow students who had signed up to be on this group ushering Harvard into the next generation. And Margaret's talking about my prophecy. Well, there you go. The class of '97 graduates. This time before the network was seemed like a very primitive time indeed. This is back in '93. In fact, I don't know if Expos was in fact the first thing to actually use the internet, but that was something we predicted. This is also fun. This is an article from the Crimson talking about this organization we put together, training students to go into the dorms and help other students wire up. This is actually fun, because this is actually a memo. You probably can't read this. I'll read it to you. This is a memo of the office hours we assigned, because we started the freshmen were the lucky ones. They got the high-speed internet before everyone else did, because we started the freshman dorms. So all of us upperclassmen who actually needed the internet for things like our classes had to keep trekking to the science center, while these freshmen got to probably the first ones out there looking at cat photos or something in their dorms. But I went through, these are all the students who were, get to each of these are all the freshman dorms, and we had students assigned to come in and help them wire up the Ethernet. And so I actually went into LinkedIn. What's that? Yeah, so Craig is on there, right? So I actually went in and did a Where Are They Now comparison. So I went to LinkedIn, and so these are the roles I was able to dig up for that initial group of students. And so yeah, we have first employee Google, right? So that was Craig Silverstein, now Khan Academy. We have CIOs, we have CTOs, we have CEOs. So I don't know which came first, being on that early group of internet science or being a Harvard student. But that's the Where Are They Now slide. And then finally, this is the other thing I'm kind of proud of. You talk about the prophecy thing. I think we claimed the mantle, the first group to ever actually create Facebook. Because back in '94, I gave this talk to, the talk that I was alluding to was addressed to alumni. And I was speaking on behalf of this IT committee. And I was a young Turk. I was a young student here to talk about all the wonders of this brave new internet we just spent all this money, I think it was like $1 million or something, wiring the dorms with Ethernet, and why this was a good thing to have done. And I talked about some of the things we accomplished. And one of the things I mentioned was we had just put the Facebook online for the CS department. And CS students could now go to this thing called the web, and they could look up each other and see pictures, and students could customize their pages. And I mentioned my friend John, who's actually here, Jonathan, he had mentioned he was going to put his mom's banana bread recipe on his page along with Harvard Frisbee schedule, which is ironic because Jonathan has a Facebook page today, and it's all about food. And so I think it's nice to see that some things actually really haven't changed. You know, the more things change, the more we come say the same. So in terms of now to kind of bring it back a little more current, Margot had asked me specifically, how did my time at Harvard help me prepare for sort of my career? And I kind of thought about that, and it's funny because there's a very direct, straight line from my current career back to Harvard, because I am now CEO and founder of a company building technology for computer games. And Margot had asked me back, so I did a thesis, and it had nothing to do with computer games. But as my thesis advisor, I got to know Margot very well. Back in 2009, she had asked me to come and speak at this thing called the High Performance Transaction Systems Conference on how games were now, in fact, high performance transaction systems. And so you have this, I love it because you have this is actually how I feel today. Here I'm at Harvard, I'm talking as a commercial guy, not the academic. Here's all these great talks on things like, you know, enterprise cloud storage services and all these things. And here I am talking about playtime's over. Right now, my talk was like games and why games are actually cool. And so this talk led me to come back in 2013, another talk at HPTS. And at that point, I was talking about how the academics have let us down. That we in the game industry were really struggling at that point to keep up with our own success. Because this is a game called The Simpsons Tapped Out. Back in 2013, I was working for Electronic Arts. They just bought this kind of PopCap I was at. And we launched this game. And this is one of the kind of big all-time fails of EA, because this is what had happened. They launched this game back in April of 2012. And it hit #1 on the App Store like right away. Boom, instant #1 hit. And within 4 hours, it had completely collapsed. The servers had collapsed. It couldn't keep up with the load. They had to take it down for 4 months, rebuild all the servers, relaunch it again in August of 2012, and then went right back to #1 and stayed there for like 2 more years. But the fact that, I mean, most companies, EA survived that 4-month outage. Most startups would not have survived. And so the question was, what had happened? And the answer is, gamers are really shitty at building powerful distributed systems. This is a hard problem. And I was sort of, at this talk, railing against the tech community, saying, you've let us down. Your databases don't work right. You can't just throw massive load at these things and have it just work. You know, and so the irony is I gave this talk, and that kind of sparked an idea. And in fact, that led to the company I now run called PlayFab, which does exactly that for the game industry, which is provide services at scale for game companies. And so we've built this company that provides all these different services game companies can just use and consume and not have to worry about scaling, because we've kind of done that for them. And the reason I'm talking about this, I'm not just in the great Harvard tradition of humble bragging. I mean, the reason I talk about this is because we're a small company. We're only 14 people. And yet, we're able to run a business that is actually at a pretty massive scale now, all because of this thing called the cloud. So part of what I'm going to talk about today is how the cloud is doing amazing things. Because I think people hear about the cloud all the time, and unless you're actually out in industry, you don't quite appreciate just how incredibly transformative this has been for us. So this gives you a sense. This is actually going back now about a year and a half, tracking how many players are playing games that my company now powers. And so we're up now to about 6 million daily active players. We're running at about 50 million monthly active players. And if you look at the number of API calls that turns into, we just recently hit a peak of about 500 million API calls per day being run off of our servers. That's a lot of load. That's something like 10 or 12,000 transactions per second. So just in the 10 minutes I've already been up here, some ridiculously large number of API calls are happening out in the cloud somewhere 24/7. And what's fun about this is we're a 14-person company. We can't afford to have one of these. We don't have a massive operations center. I mean, we all go home and sleep at night, right? So how do we do that? How do we run a service that runs 24/7 with millions and millions of players around the world in every time zone that doesn't go down? And the answer is the cloud. And the answer is, there's some really neat things that have happened that allow small companies like ours to have that kind of scale. So what are some of those things? So I'm going to talk about a couple of them. One of them is this software as a service, Saas. You may have heard of it. It's amazing what that has meant for small companies like ours. In particular, we now can stand on the shoulders of giants. Because the real transformation in my mind of the cloud is that companies can now plug together like Lego blocks all these other services from all these companies in a pretty seamless way. So for example, we ourselves live on Amazon Web Services. That gives us things like compute and storage and data pipelining, these kind of basic building blocks. But we also rely on things like Snowflake, which is a massive data warehouse in the cloud that we can just subscribe to and use and not have to manage. Pingdom is a service that does nothing but ping your servers every 30 seconds to make sure they're running. And if they don't run, they tell you. But it's someone else's data center, which means that when we go down, this is how we know about it. And it's a real thing, and it's very useful. Datadog is a massive service that collects all of our metrics. So we send Datadog 70,000 different numbers on a continual basis, and they give us pretty graphs and let us know how things are performing. Zendesk is our ticketing system. Loggly does nothing but scoop up all the server logs from all of our servers and put them all in a massive Elasticsearch-powered system where we can go in and search them. So if something goes wrong, we can go back and conduct kind of forensics to see what happened off of Loggly and not have to manage our server logs ourselves. Status page does nothing but run our status page. So if you go to playfab.com/health, there's a green list of servers that are up. And this really helps us because recently Amazon S3 went down for a couple days, and it was a big deal. They didn't go down. So we were able to have a little red light saying one of our services was impacted, and people could go and find out what was impacted. And that didn't go down because it's a whole different data center. Stripe is our payment system. VictorOps is my favorite. VictorOps does nothing but essentially paging services in the modern day and age. So if Datadog does all of our monitoring, if Datadog detects a problem, and it's a problem big enough that it needs to wake someone up, it then automatically tells VictorOps, hey, there's a problem. And VictorOps has a whole call list. Our engineers take turns being on call. And there's a whole call list rotation. And it's all set up in VictorOps. And it'll automatically start calling and paging and texting. And after 10 minutes, the first person doesn't answer. It'll follow over to the next person, until someone eventually wakes up, goes online, turns off the alarm, and solves the problem. And that's how a 14-person company can run a 24/7 service. And the thing is, it actually kind of works. We depend on all these other tools we depend on. So GitHub is our source control, right? I mean, the nice thing about PlayFab is we're 14 people. You could burn down our entire office today, and zero would change in our business. There's not a single thing stored in our physical office that matters. Everything's in the cloud. All of our source code, everything. We don't, we're a completely virtual company. We have an office just for convenience. It's nice to have a place to get coffee and chat with your coworkers, but we don't have to. Slack, frankly, is our new virtual office. Slack is a system of, and everyone here using Slack users, you all should be on Slack. Slack is basically it's like a BBS, but like modern BBS. It's a thing we use to communicate with our colleagues and post files. It's also how we do all of our customer support now has moved to Slack. It's how we communicate with our customers and keep up with what they're doing. Trello is our board for tracking tasks. Jenkins is our continuous build and automation system. So when you check in a build, anytime anyone checks in anything in GitHub, it automatically fires off a job in Jenkins to run through a few thousand tests, make sure everything passes the automated testing. Once it passes, Jenkins is how we then roll out and deploy. It's all automated, the deployment process. Fabricator is our system for code integration. I can go on and on. But the point is, these are all building blocks that a company like ours can roll along and just wire them all together and start using them. And that, to me, is really the transformative power of the cloud. This, for example, is a screenshot from Datadog, just a little glimpse of probably 20 of the literally hundreds of different metrics and graphs we track to measure the business. Every one of those has automated alarms behind it, which is how we know when things go wrong. This is actually Slack now. This is showing inside Slack what happens when something goes wrong. So I went back in time. You can see at the top there, triggered PlayStream processor high latency on shard. That means basically the latency started growing on one of our key metrics. So something's wrong. If the latency is growing like that, it's a bad thing. So you can see VictorOps now chimes in, notify, trying to contact Reeves for 2 incidents, sending SMS. He then acknowledged it. So once he acknowledged it, it then canceled the paging. And then Matt, one of my CTO, jumps in and says, I'm looking at this now. He then fixed it. VictorOps is resolved. You can see the Datadog alarm went down. Everything's solved. And this whole thing took from 8:50 to 9:55, about an hour total. But basically, it was solved in about 20 minutes. So that's an example in real time of what happens under the covers when you don't have a dedicated 24/7 network operations center, but just a bunch of engineers working on the laptops, wherever they happen to be. This is a screenshot of our continuous integration, just to give you a sense. Every time, this gives you a sense of all different automated tests we run on a regular basis every time code gets checked in. This is actually the thing that's probably had the biggest impact on my business. So PlayFab, 14 people. We've had 10 minutes of downtime in 3 years of operation, right? That's like 5 nines or some crazy number of nines. And part of the way we do that is the cloud. So it used to be in the bad old days, you had dedicated hardware. You had to actually physically buy servers and rack them in data centers. And that was a major capital expense. So we never would have been able to afford 2x the number of servers. We would have had probably 1.2x or something the number of servers. And so what it would have meant was you're running a given build. It's time to roll out your next build. You do what a lot of people do. They say, we're down at midnight. From midnight to 2 a.m., we're offline. So you take it all down. You switch to a new build, and you spin it back up again. That's how you used to do it. Now, we simply spin up an entire complete duplicate of everything. So we have PlayFab running with all this stuff. We push one button. It basically spins up a complete copy of everything. Duplicate servers, duplicate databases, everything that's duplicated. You then start running, and then we have this big DNS switch. We basically switch 1% of the traffic over. And then we start running on that. And then if there's no problems, after a couple of minutes, we then switch 10% over. And if that works OK, we then switch 100% over. And once all the traffic is running on this duplicate version, we just shut down the old one. And it all just kind of goes back into the cloud from whence it came. And we're now running on the new build. And that's how we switch over traffic. And that's great, because it means no scheduled maintenance windows, no scheduled downtime. Where it really becomes impactful is when you've got a problem. Because in the old days, you'd switch everything over. You'd start ramping up your new build. Oops, you got to roll back. And then you got to do it all again just to roll back, if you can. And a lot of times you can't even roll back because now your databases are completely screwed, and now you're just stuck. In the new system, we switch over. Oops, problem. We just switch it off. Maybe no one even noticed if we're lucky. And that's the real power of what the cloud has meant for how we can run these massive systems. OK, so I promised a little glimpse into kind of what I think is where we're going. So that's the cloud. And the cloud is so powerful because Amazon and Google and Azure now is providing all these resources. You can just go online, and with a credit card, you can basically get, I love it, they call it compute. You can get compute. Compute is servers, EC2 instances. You can get storage, databases. You can get all these services. Where it's going, though, is actually, it's interesting. One of our largest customers, this is the journey that one of our largest customers has gone down. So it's a huge game company. I'm not going to name them, but they've got lots and lots of players and lots of games. They've been around for a long time. They used to run their own data center, and as you did. And then they realized, well, that's too expensive and too time-consuming and too much resources. So they went to Amazon, as a lot of people did. And Amazon was great, and it saved them a lot of money. They could lay off a lot of people, and they could cut their costs or reallocate to other things. And that was great. But then they realized that was too expensive, because they're still doing basically the same thing they did before. Just they didn't have to physically rack servers anymore. But they were still having to spin up servers and manage storage, and things could still go wrong. You could still end up with running out of compute power or whatever. So then they went to Google Cloud. And Google Cloud was great, because the way Google Cloud is different from Amazon is you don't need to worry about the physical servers anymore. You literally just give it the code, and it will just sort of magically give you enough compute power to run your stuff, as I understand it, sort of my layman's version. So that was great, because it meant they could let fewer people go. Fewer people needed now to run their services. But they still were running code. They still had to write the code. And this is a large company that has a massive, very powerful info security group, such that every single line of code that's written is seen as potentially company-ending code, because any code out in the cloud, any code written on the server side could introduce hackers and viruses and things. So it had these massive security processes. So that was still too expensive. So now what do they do? We're doing it all for them. And literally, they write zero code now, because PlayFab is this magic set of services that does everything for them. And so basically what they've done is they've gone from having to build and architect their own back-end services. And that's my poor job of trying to diagram what that looks like. But they went from having to build and write their own code in the back end, which was expensive, to just, we have like 300 different APIs. And they just use our APIs. And it's a vertical set of APIs. So we've got APIs for things like update user data, add friend, get user inventory, add user virtual currency. I mean, these are pretty not sexy APIs, but they're very tied to what games do. So we've got this nice set of 300 different vertical APIs for games, and they just use them. And that's it. It just works. And when I look at what's going on in things like Google Firebase, same thing. Google Firebase is similar. It's a set of services for any mobile app. And the goal now is to no longer need servers at all. You just consume, I mean, you're still using servers, but not your servers. You're just consuming services from these APIs that are increasingly tuned to your particular need. So we do this for games. Firebase does this for sort of broader mobile apps. I'm sure there will be others. And so my prediction, such as it's worth, is that we will soon be in a world where more and more this will crop up, servicing these various verticals. And you will no longer need to worry about your servers at all. You just will build your apps, all client-side, and all the magic that happens out there is all done with APIs. And that's sort of the world we're heading towards. So Anyway, hopefully that sort of a fun tour of sort of what I'm up to, where we've been, how Harvard has kind of got me to this point, and I owe my start to some of the early committees and thesis advisory from Harry. So with that, I think we have a little bit of time for questions, a little bit, about any of this stuff or none of it. Yes? Okay, great. Happy to chat more. Oh, over there, yeah. Distributed risk, like catastrophic failures?
You have 14 suppliers distributed all over the internet. When they go down, what happens to you and how do you manage?
Yeah, huge problem, and you're exactly right. So we've gone from sort of managing all of our risk ourselves to now having all these other people kind of distributed the risk out. On the other hand, I think a couple thoughts there. One is, so Amazon is obviously our biggest supplier, and they are able to address risk in a way that we never could. So for example, we run in what's called 3 different availability zones. Availability zones are completely different data centers, different power supplies. As a small company before, we would have had probably 1 data center with 1 power supply. Now we have 3. And so right away, we're already getting benefits of scale. We've had situations where one's gone down and we've been OK. Also, things like denial of service attacks. We never could have afforded to defend ourselves against concerted denial of service attacks. Amazon has all these layers in place to prevent against that. So I trust them way more than I ever would have trusted myself to sort of defend against those things. The fact that we've got all these suppliers now doing different things, I actually think it's built in a certain amount of fault tolerance, because no one of those, let's go to Amazon, no one of those is necessarily mission critical, right? A piece can go down and we degrade our service a little bit, but it's not out completely. If logly goes down, we lose our log files for a while, but the service still runs. If Amazon goes down, we're kind of screwed, but that's really the only point of failure. So I guess the compounding of the different services I actually see as now a strength versus a weakness, and especially because they themselves are often running on different dependencies. All we need to do now is add Azure or Google, and we'll have actually pretty good backup even for Amazon at this point. So anyway. Yeah, thank you.